Yeah, so I'm going to cover two major things in this presentation. What we're going to cover is the process that we go through to merge community contributions to our core projects. So that's Puppet, Factor, Hera, Standard Lib. And then in addition to the process, some automation and tooling that we've implemented this past year. So in the first half, we'll cover the process and what changes we made. In 2012, we identified that there were quite a few challenges with the process that we had in place. Pull requests were piling up. We weren't getting back to community members in a timely fashion. And then so we made a change in January of 2013, and then the results from that change are going to be presented in the second half. So I think this is applicable for any open source project. If you're running your own small open source project that you accept contributions from other people, hopefully you can take some of these lessons learned and apply them. And then in the second half, we're going to talk about some of our automation and tooling. So we've put together some tools to automate some of the more tedious aspects. So we're using GitHub, TravisCI for the testing, and immediate feedback. It's not actually our official CI system or anything, but it does give contributors more rapid feedback. We're using Trello to keep track of work, and a small open source project that we wrote to sort of connect all these together. And then we'll have some questions at the end. All right, so the big takeaway is that we've been able to merge a lot more patches by having automation and a well-defined process. We also found, so these are some of the key points to keep an eye out throughout my talk. We've dedicated people to the community pull requests, and we found that that worked really well. Context switching is something to try to reduce. If the teammates are doing too many different types of work, it can be a real challenge. And then the automation itself, so that helps reduce context switching, and we've been able to provide a single pane of glass to see all the work that we need to do. All right, so let's talk about what was going on in 2012. All of the work on Puppet, Factor, Hera, and Standard Lib, which are some of our core projects, were being performed by the platform team. And so the platform team had a large number of responsibilities. We had to do bug fixes on all of these projects. We had to do new feature development. We had to handle security incidents when they arose. And we also had to take care of the community pull requests. And so, we took a look at this, and you can sort of divide these four things into two different types of work. We had unplanned work, which are the community pull requests. We don't know when somebody's going to contribute new code, right? We get the code drop, and then we have to respond pretty quickly. So we had no idea how to plan for that. And then the security incidents, right? Those came up, and we really had to drop everything and do all hands on deck to address any security incidents that come up. But then the bugs and the features, we could plan for that. So we could actually integrate those into our sprints and plan which bugs and which new features we were going to implement on a week-to-week basis. So the problem that we were facing was that we kept switching between these two different types of work on a day-to-day basis, even sometimes on an hour-to-hour basis. I might work on a new bug or a new feature in the morning and then try to take care of a pull request in the afternoon. And it just got to be a real issue. So what we saw, toward the end of 2012, is pull requests were always being deprioritized, right? New feature development, bug fixes, those would usually rise to the top of the priority list. So this is sort of the outcome that we saw at the end of 2012. Our backlog of community pull requests was growing. It was already pretty big. We weren't responsive, so a community member would submit code, fixed a problem. We might not get back to them for months, which is really bad. It made us feel really bad, right? We had to implement sprints to try to catch up and burn down that backlog. And we're actually getting public complaints from some of our key community members that had been working on Puppet for a really long time. And then all of this stuff sort of added up to stress out our whole team. It's like we actually felt like we were not meeting the needs of the community, which is sort of bad. So, we try to measure a lot of this stuff, and you can sort of see the results. This is actually on our puppetlabs.com/community page. Dawn Foster she gathers a lot of great metrics on the community and the involvement. But you can sort of see the axes is a little bit difficult to read on the label, but these are the days and the months in 2012. So starting in February, we actually had a triage-a-thon. Everybody got together and categorized a lot of the open issues that we had. But throughout the year, so we got to July, it had been growing quite a bit. And we were up to 80 outstanding pull requests that hadn't been merged. So we decided to do something about it. That's when we had a pull request sprint. So we sort of focused everything on just merging pull requests. We didn't do any new feature development for that sprint. We didn't do any bug fixes. And that did help, right? It got it down from 80 to 50. We did another sprint for the Puppet 3.0 release last year, but it just started to grow again. So you can sort of see when we hit December, it's on an upward trend toward the right of the graph here. So, it was okay to do these sprints and try to address the growing backlog, but it didn't feel like a sustainable fix to the problem. It just sort of felt like putting a Band-Aid on it, and yes, we're going to address it for a week or two, but it didn't actually make the problem go away. So in January, we decided to make a change to our process that had the intent of making the problem go away for a longer period of time. So we established a dedicated community team, and this was just me to start. So we said, let's just figure out if one person can try and focus on this and sort of make the problem go away. So, I didn't have to worry about some of the planned work that the platform team was also focused on, but I did have a goal of any new incoming pull requests that came in from a community member, they'd at least get a response with a clear next action by 2 p.m. the next business day. So this was meant to stop the backlog from growing. So at least, if we were sitting at 80 pull requests, we weren't losing ground, and then we could chip away at that backlog over time. The community team is focused on one type of work, so we were really trying to focus on the community pull request. It was unplanned, but then we could develop a process around that. So we didn't eliminate context switching. I mean, patches that come in from the community, they're inherently a context switch because you don't know, are they fixing a bug? Are they adding a new feature? Is it a really big pull request? Sometimes Brice Figueroa, I don't know if you guys have seen any of his talks, he'd go off for months and write these giant new huge pieces of functionality. So it's definitely still context switching, but we still tried to reduce the type of context switching. So we're not going between the security fixes and the new feature development and the bugs. So then the platform team, they had reduced context switching as well. They didn't need to worry about the community pull requests as much. I still could consult with them if I had questions on some of the bigger changes that were being made to Puppet and Factor. But they didn't have to worry about it on a day-to-day basis. Like, if somebody submitted a pull request in the afternoon, what are you going to do about that in a quick response? So they got to focus on bug fixes and new feature development, which is largely planned work. Security incidents, they still fell on the platform team, which is unplanned work, but they're special, right? I mean, you got a security vulnerability, you need more than one person focused on it, so that's sort of why we decided to keep security incidents within the realm of the platform team. But anyway, it resulted in reduced context switching for everybody. It didn't eliminate it, but it reduced it. So yeah, sort of went through this slide as well. The platform team, or the community team has one type of work, the unplanned pull requests, and then the platform team is largely responsible for bug fixes, new features, and security incidents. All right, so these are the results of just this change in process for 2013. So we implemented this in January, and you can still see the overlap from July of 2012. We were on that upward trend on the last graph that I showed you. We doubled the size of the team by adding Adrian. And he's been merging way more than I have. So like he's been cranking them out. You guys probably see Adrian a lot if you're. I forgot to ask early on, who's committed a patch to Puppet? All right, gone through, so we got 3. Okay, so if you've committed a patch, you've probably worked with Adrian at least recently in 2013. Yeah, he's been killing it. So with him focused on it, we've had the downward trend. So remember, it was pretty bad in 2012. We were up to 80 open pull requests. Some of them were many months old that hadn't gotten a response. Throughout 2013, all new pull requests were responded to by 2 p.m. next business day, which is pretty good. I mean, there were a couple lapses, but at least it wasn't a week, right? It wasn't a month like it was in 2012. And we did manage to burn down through the backlog. So we're down to a point in April and May where there were only 12 open pull requests across all of those projects. So that's a pretty good result just by changing the process. So the key takeaways there are we found dedicating at least even just one person, having a dedicated person that didn't need to context switch between all those different types of work really helped. Allowed us to decrease the backlog. We had a faster response time to our community. They weren't going months without a response. And then, yeah, new pull requests within 2 business days, or 2 days instead of a month. So then, that's pretty much the change in process that we implemented. We also put into place some new tooling in there. So this is Trello. How many people are using Trello or have seen? All right. We've got a lot of stuff on our board. This was spread out over a ton of different systems. So we use GitHub to actually accept the pull request and the code, have the commentary, which a pull request is a combination of the actual patch and the comments. We use Travis to provide immediate feedback to the code contributor. That's in addition to the CI system that we run internally at Puppet Labs that does the full test suite. And then we have Trello for the items that are the work in flight. And so we decided to add one additional tool that would move all of this stuff into one place, so we didn't have to context switch again between all 3 of these different tools. So that's where Puppet Webhooks comes in. It's a Heroku app. But why add one additional tool if we're already suffering from too many tools? But the idea was we had too many different sources of information, so we wanted to get all of the information that was critical to merging that community contribution or somehow bringing it to a clear resolution in only one place. So the Puppet Webhooks tool, it's pulling information in from our issue tracker, from Jenkins and Travis, from GitHub, from our contributor license agreement system. Has the contributor signed a license agreement? Can we merge their code in? And then it presents it all onto Trello. So the information that we're putting in, this is sort of everything we need to make a decision on what to do with a community pull request. So there's a Trello card. We get all the code comments. So when somebody comments on GitHub, those are automatically copied to the Trello card. We get a contributor bio, so we can actually see who made the contribution, what company they came from, so we can sort of build up in our mind, an understanding of where they're coming from. Like before we even had the bio, it's just the GitHub username, and it's like we're dealing with so many pull requests, we could lose track of who everybody was. Yeah. Sorry, I'm not quite sure why I have select contributor in there, so we're just going to move on. This is what the cards look like in Trello. So we actually have a bot, like a service account, that's posting all of this information into the Trello cards. The app itself, again, is running in Heroku. And so you can see like the activity from the contributor license agreement. It's a little bit small here. But the activity from the contributor license agreement, it's copied over to the Trello board so we can see it all in one place. The activity on GitHub is copied as well. And then we have a special keyword. So if I put a comment in GitHub that just says summary : that'll automatically get copied over here and then extracted for a weekly summary email that we send out to the Puppet Dev users list. And this can sort of give feedback to everybody who made contributions for that week did their patch make it in or not? If it did make it in, what version of Puppet or Factor will it get released in? That sort of thing. All right, so again, the contributor bios. This is Eric Sorensen, our product owner for Puppet. All of this information is copied from the GitHub pull request, and then we can, again, deal with it all in one place. So getting this all on Trello, we had to design some of the columns to figure out how to move these cards from left to right. So the goal there was to always make sure that the people who were contributing code to Puppet had a clear next action. So we didn't want it to be blocked on us. We wanted to make sure that they knew what to do next, whether it be writing new tests or improving some documentation or anything like that. So cards initially get created in a response needed because we need to look at them. Then we move them over from accepted to doing. We were trying to somehow do planned work for community pull requests. So we thought we could do some initial planning on Monday and pull a certain number of community pull requests over, do a sprint for that week. It just didn't really work. So accepted actually ended up being a dead column. We really just tried to deal with them as soon as they came in, and that seemed to work a lot better. Waiting on contributors, once we've provided clear next actions, we're sort of waiting on the contributor to act on that. We'd put the card there. If we're waiting for greater than a week, we move the card over there so we know that it's been going on for quite a while, but we're waiting on the contributor to get back to us. And then if we do merge it into the code base, it'll have to go through our production CI system internally, which the full test suite runs every night. So this is a reminder for us to check it in the morning. And then finally, if it goes through CI, we've finished it this iteration, and this is the column that gets scanned for that summary tag so that we can generate the automated weekly email. All right, so the Puppet Webhooks project, I mentioned it's a Heroku app. And so the way all of this ties together is that we use the GitHub webhook configuration setting so that anytime somebody creates a new pull request on GitHub or pushes code, we actually get an HTTP callback to a web service, and then we can take action on that callback. So all this is just a screenshot of the GitHub UI where you can add a new webhook URL, and you can see we're going to the Puppet Dev Community Heroku application. And then so what happens is whenever a pull request is opened, GitHub posts information about that pull request over to our Heroku app. So it's an event-driven model. We're not polling all these different projects, which works pretty well. We then store that JSON data into a delayed job queue. Delayed job is just a Ruby gem that allows you to do asynchronous processing. And then the Heroku app, it starts a delayed job background worker to actually act on the pull request that just got created. So that's the thing that does all the work of creating the Trello card or checking the TravisCI build status. And the reason we did it this way, rather than just like doing all the work directly in the web app itself, is Heroku gives us 750 hours for free, right? So this is, I've been debating if this is like abusing Heroku or not, but the math adds up. So if you sign up for Heroku, they give you 750 hours for free. If you do the math, to run the web app, it's for 31 days at 24 hours a day, that's 744 hours, right? So you have 6 extra free hours lying around. And we decided to use those extra hours to do the background delayed job, right? Because those can take 2 or 3 seconds. You don't want your web app tied up for 2 or 3 seconds. So all this works pretty well. There's just a gem called workless that automatically spins up and down those background workers. So you're not running 2 processes persistently all month. But yeah, this works really well. So it takes 4 or 5 seconds to move all the data around, or somewhere around there. It depends. But we've never actually exceeded the 6 extra hours. So if you've got a small open source project, you can download this code, load it up in Heroku. You do have to give them your credit card to use their API, but as long as you stay within that 6 extra hours, you're not going to get billed, which is pretty good. So here's what it looks like on the Heroku side. Heroku web interface, we're running our web process persistently all the time, 24 hours a day, 7 days a week. So that takes 744 hours. And then the worker that actually copies the cards around and does all that stuff, that's just turned off. But whenever we get work to do, it automatically turns on. When the work finishes, it turns itself off again. All right, so what have we automated with this project? Like I mentioned, a new pull request creates a new Trello card. Whenever somebody comments on an existing pull request, that comment is automatically copied over to the Trello comment. We reach back into the GitHub API and collect the contributor biographical information. We get their gravatar image so we can see a nice picture about them. It automatically calculates a due date. So I mentioned 2 p.m. next business day. The Trello cards have a nice little, this card is due at, so we actually used another Ruby gem that allows us to figure out the next business day for all US holidays. So, Labor Day weekend, it'll be 2 p.m. on Tuesday instead of Monday. So that works out pretty well. It talks to our CLA app, which is another web app, to figure out if that contributor has signed the contributor license agreement. And then every week, it generates a weekly summary of all the work that we've moved over to that last column. So the things that we have event handlers for in the web app, but we haven't really implemented any behavior yet because we don't really know what to do with them. If a pull request gets closed, we still get the event, and we could do something with it, but we didn't want to just delete the Trello card, or we didn't want to, we still want to manually do that just so we know, yes, this pull request is closed for a good reason. But there are hooks there if you wanted to take this code and implement your own things. When somebody pushes new code, we have a hook for that too, but we don't really have any interesting things that we're doing when new code is pushed to an existing pull request. And we do get an event when the TravisCI test completes. But we already get a nice red-green button on the pull request from GitHub. So we didn't really implement a lot of work to present that on the Trello board. But if you wanted to do this for your own project, all those event handlers are there. So at the end of each week, we send a summary email to the Puppet developers' users, or the mailing list. And this is somewhat automated. We haven't fully automated it yet, but at least the generation of the email is automated. So we scan through all the cards that are in finished this iteration, and then look for that summary tag. And then we actually, I didn't want to maintain my own database or persistent store or anything like this. So it just posts a markdown file back to a gist on GitHub, and it's using gist as a persistent data store. But what we get from that is a nicely formatted markdown file that we can just copy and paste into an email. So yeah, it's reading a liquid template from the GitHub URL, and then it fills out that liquid template with all the cards that have been completed, and just posts the markdown back to gist. So I don't know, it's pretty hacky, but it's been running for 8 months now, and as much as GitHub goes down, it's actually not that bad. It's a cron job, so it runs it again anyway. But yeah, we managed to avoid any persistent state in the app or in the database, so we don't really have to worry about it. As long as gist is up, we're fine. This is what the liquid template looks like. So we just say, the Puppet Dev community summary, it's markdown. So how many finished cards that we completed that week, and there are 3 main sections, right? Let me go through and look at that. Oh, I don't actually have an example. Yeah, these 3 sections. So we've got how many cards we finished in the week, how many we merged into the code base itself, how many pull requests we closed but didn't merge. They might have been sitting there for a month and the next actions weren't addressed or whatever. And then other is just if we forgot to put the summary tag in there, so we don't know what it was. Yeah, so that works out pretty well. So if you're subscribed to the Puppet Dev mailing list, you'll see these come out on Monday. mostly. This is what it looks like on GitHub. So we just periodically run this command. It's actually automatically run from cron every day, but we just send the email on Mondays. Yeah, so that's it. So from the tooling side, it's, you can see we were switching between all these different projects like GitHub, Trello, Travis, our issue tracker, our CLA application. So we did decide to add one more tool to just put all of that information in one place on the Trello board. We didn't have to context switch between all those tools. It is open source, so if you wanted to try this in your own project or whatever you'd like, you can just grab a copy of the code from Puppet Labs/Puppet webhooks, and it deploys directly to Heroku. So as long as you've got a credit card to access their API to spin up and down the workers, you can pretty much get started right away. So in conclusion for the whole thing, the process changes, context switches were not very good, dedicated people are way better. And on the automation side, we're using a ton of different tools. So we automated all of them together to present the information in one place. And as a result, we're maintaining our open pull requests at around 15 to 10, which is way better than the 80 we were at last year. We're responding way more quickly. Yeah. So that's pretty much it. Any questions?
I think the good thing is, like, it's not super surprising. It's like, pretty elegant solutions to, the problems that a lot of teams have, or the same kind of problems. And so it's nice to get that insight into it. Like, okay, well, we threw another person at it, that kind of helped, but that gave us a chance to automate and doing it correctly.
Right. Yeah. Yeah. I think it's not so much a question, but a comment of the dedicated people and actually having somebody be able to focus on building some automation around it. Yeah. When we were dealing with all the different types of work, I mean, I couldn't even think about how to write a new application to automate all that stuff. Actually, I did a lot of it on my Christmas break, so it's not like I was doing a ton of that during business hours, but we did have the bandwidth to do it, and we do now. Like, Adrian has been improving the process a lot. We talk every week in our one-on-one about how to improve the process, how to improve the tooling. And then other teams inside of Puppet Labs have started using that webhooks project, because all you need is a Trello board. Trello is free to start with, too, so it's pretty lightweight. Yep.
And so this is, like, strictly, at the time at least, just what you were using for community stuff.
Yes.
And you're saying that the process has kind of been adopted internally for features.
We actually started using Trello first on the platform team. Sorry, the question was, did we start using this first on the community team, and then did that get adopted by other teams inside of Puppet Labs? And it was actually the other way around, because like in 2012, we didn't have a community team at all, but the platform team that was responsible for pull requests and features and bugs, we did start using Trello to manage our sprints and our planned work, but it wasn't working. It didn't feel right because there was those really two different types of work. We'd get a community pull request. We wouldn't know what to do with it on our Trello board because we already went through our planning session on Monday. The pull request came in on Tuesday, so then it would have to sit there until the next Monday, or if we were on a 2-week sprint, nearly 2 weeks, it would have to sit there before it even made it onto the board. So it's like, well, this isn't working for the community. Like, it works for planned work. So at that point, when we made the changes to the process in January of 2013, we established a second Trello board. And we're like, this will allow us to sort of define our own new process, or a slightly different process. We didn't try to make it radically different than the way the platform team had been working, but we wanted the ability to add new cards to the board so that we could flow them through immediately when a community member gave them to us, so they didn't have to wait. So does that help?
Yeah. Absolutely.
Yeah. Sweet.
The subset of smoke tests that are used under Travis for a particular pull request in,
Sure.
In context, and how that differs from the full production CI?
Sure.
Thanks.
So the question is, could I talk a little bit more about the subset of tests that are run under Travis versus the full suite in our production CI? Is that right? Yeah, so Travis, it's really, we tried to turn TravisCI on, I think back in 2011, and we configured it wrong. So it spammed everybody with like every build failure ever. So we didn't turn it back on for a while, but we decided to turn it back on again in January of 2013. But it's not meant to provide an authoritative answer for like, the build is passing, because we run a much more comprehensive test suite internally. So that's Jenkins. We do spec tests on a large number of platforms. So we do spec tests for Red Hat 5, Red Hat 6, Debian, Ubuntu. We do integration tests, and then we also do integration tests with Puppet Enterprise. So like all these different platforms, different levels like spec, integration, and acceptance. But that's pretty big. So it's hard. We had a real challenge to expose all of that to provide immediate feedback to a contributor. Because one of the most common things that we run into with community pull requests is like, great, you wrote some code, but it broke a bunch of tests. So like, I can't just merge this right now. But they weren't getting that feedback for 24 hours, right, until the test suite ran. And that was at jenkins.puppetlabs.com, so we didn't have it integrated with the pull request yet, so that the community member might not even see it unless they were actively looking in a different system. So TravisCI, it's really only executing the Ruby spec tests for a small number of Ruby runtimes. So I think it's 187 and 193, and we did just turn it on for Ruby 2.0. But it's just meant to be a really low level, like, does this pass the minimum bar? Is it likely to flow through the full test suite? Like, can we predict that we can go to the next step? But it provides that more immediate feedback, and it's right there in the pull request. So the community contributor can see, like, oh, I opened the pull request, 5 minutes later, I can see that there's the red button that some tests failed. And then it's a little bit more self-service then, right? So they could interact with it. It's like they could update their code, do a force push back to the pull request. Travis will rerun automatically. So that's sort of the intention, is to provide that more immediate feedback. Does that help? Yep, sweet. All right. Other questions? Sweet, well, check out the code if you're interested. It's on GitHub. Great, thanks.